Hi folks, and welcome to this video on specific heat capacity. What we're going to do today is learn the various factors which will affect the rise or change in temperature when we heat up a certain substance. We're going to learn an equation which expresses those changes and then practice using a question. And hopefully by the end of this you should have a really good understanding of all of those concepts. So let's get to it. What we've seen in lessons is that when we heat up a substance, one thing that can happen is the temperature can change. Okay. Now, this is because we've supplied heat energy to that. A small note, when we're describing anything to do with heat, we use the letter Q to represent the heat energy. Okay, so anytime you see the letter Q in subsequent lessons, that's always going to mean heat energy when we're thinking about thermal processes. We've got another symbol there, which is theta. Now, we've seen that before as an angle, and in this case, we're using it to represent temperature. So what we're saying here is that if we add Q, then theta will change. Okay, and what we're going to do is we're going to learn an equation which combines these two variables together, Q and theta, via another couple. Now, you'll see on the slide, there's a fairly complicated triangle for this one, and if you like using triangles to remember equations, by all means, copy this down. Okay, you notice there on the top row, we've got one space, and we've got 3 on the bottom. Now, let me show you the equation, and we can kind of fill this in as we go. The equation we use to calculate heat energy is Q equal to mc delta theta. Okay, so if we're looking at our triangle, okay, we put in Q. Q is our heat energy measured in joules. Okay, just because it has a different symbol doesn't mean we measure it in any other way. Okay, Q is going to come in here. We'll go through the other factors. Well, M is simply just the mass. Okay, and mass is going to go to the bottom of my triangle. Now we think about this. What this means is the more mass I have, the more energy I need to heat it up. And that hopefully makes sense. If you've got a full kettle or a half full kettle, it will need more or less energy depending on how much water's in there. So the less mass, the less energy, more mass, more energy. I think the one which students get stuck on is the next one, which is the letter C. Now, C refers to what we call the specific heat capacity. Now, this is a number which is associated with all materials, where every material has its own specific heat capacity. Water has a specific heat capacity. Iron has a specific heat capacity. Wood will have a specific heat capacity. And it's measured in joules per kilograms per degrees Celsius. Quite complicated units there. Okay, we're talking energy per mass per temperature. We'll come on to a slightly more formal definition of specific heat capacity in a second, but for now we'll just enter it into our triangle and we'll put it down in that bottom one there, C. The last one is delta theta. Now we said theta was the temperature. Delta means change. So this is the change in temperature, and we're measuring that in degrees Celsius. Okay, and so that's going to come here on the bottom right of my triangle. So we have 3 variables there, and the usual thing is if you cover one of them up, hopefully that helps you know what to do. Okay, just being aware that we're using 3 as opposed to 2 variables on the bottom, so it's a bit more complicated than, say, the original speed, distance, time triangle that we've used before. Now, just as by way of a more formal definition, if we're given the specific heat capacity, what that means is we know the amount of energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. So if the specific heat capacity of a substance is 500, it means if I have 500 joules, I can raise the temperature of 1 kilogram of that substance by 1 degree Celsius. What we'll do is we'll see an example of this in the next slide. If you're not ready to move on, pause, take notes, add to whatever you need to do. But if you are, then keep watching and we'll try an example question. Here we go then. All right, let's imagine we have water. Water is a very standard example, has a specific heat capacity fairly well determined of 4,200 joules per kilogram per degree Celsius. What that means is if I have a kilogram of water, then I need 4,200 joules to raise the temperature by 1 degree Celsius. Now, slightly harder question for this one would be to say, what's the change in temperature if we had 4 kilograms of water and we are going to supply 80 kilojoules of heat energy to it? Now, you may be in a position to have no idea what's going on here. By all means, watch on. However, you may have an idea already. That's where I suggest you pause, try the question, and I'll show you the answer afterwards. So feel free to pause now If not, keep watching and we'll see how we do it. Let's think about what we know in the question. We know Q, the heat energy, 80 kilojoules or 80,000 joules. We know M, 4 kilograms, and we know C, 4,200. So what we're left with is delta theta. Okay, we know M, C, and Q. So what I like to do in this kind of situation is actually input the numbers. Sometimes we might rearrange the equation so that you can just directly calculate. However, some students are uncomfortable with that, okay? Particularly at a sort of pre-IB level, so you might just be happier putting in the numbers like this, okay? With 80,000 on the left, we've got 4 times 4,200 on the right. Okay, as long as my maths hasn't failed me, then we've got 80,000 equal to 16,800 delta theta. All we have to do now is divide both sides by that 16,800, and we end up with a temperature change of 4.76 degrees Celsius. So you notice there we've done actually a slightly sort of more complicated question where we're not calculating energy here. We are calculating the change in the temperature by dividing the energy by the mass times that specific heat capacity. Okay, that's all for now. If you've got any questions, as ever, please do ask. If not, go forth and try some practice questions.